Question for you. Do variables make you groan? Do exponents make you cry? Does algebra make you sigh? Then you're in the right place. You're here with math with Mrs. Lehman. Great intro, guys. Welcome to Math with Mrs. Lehman. We are in my 6th period class right now, and we are going to solve for A and check. So our first example here is a multiplication equation, all right? So your goal in any equation is to isolate the variable. You want to get all your numbers on one side and your variable on the opposite side of that equal sign. So how will I go about doing that? It's so hard to pick people and they all have their hands up. It really is. Cam? Divide. Divide. Very good. I'm going to divide by that coefficient. Whatever number is attached to that variable, we're going to divide by that. So in this case, 4. All right, so that's going to cancel out because 4 divided by 4 is 1, and we'd have 1a, and we would just write that as a. We have an equal sign, so we're going to bring that down. And what is 84 divided by 4? Cassie, nice and loud. 21. 21, very good. I'm not quite sure why I picked this as a question because kids like to very annoyingly say 21. I don't know, but anyway, so 4a equals, 84. So when you do your check, what I want you to do is plug in what you got for a value for a, in this case 21, and then this right-hand side of this, in this case, the side where you're not substituting in anything, you're kind of almost ignoring that for now because you want to check to see if your work actually comes out to what the answer is. So if you multiply 4 times 21, you will get 84, and that is exactly what it needed to be. So, does anyone have any questions on this? Okay, we're going to go on to this one. Now, a over 13, when you see a fraction like this, that means divided by. So a is divided by 13. You're not going to see it written like this. You're going to see it as a fraction, like down here. So how would I get rid of that dividing by 13? Cam, nice and loud. By. Very good. She's very soft-spoken. Multiplying by 13. So you're going to multiply by 13 on each side. What that's essentially doing is you're canceling that out. You would be just left with a equals 7 times 13 is 91. Yep. So you would go to the side and do that multiplication. 7 times 13, and you would get a 2, and you would say 7 times 1 is 7, plus 2 is 9. So you would have an answer of a equals 91. Oh, that was weird. Okay. Any questions on that? All right, moving on. We are going to flip a few pages from where we were yesterday and go to lesson 33, which is a lesson on solving inequalities. So the same steps apply for solving inequalities that we use for solving equations. So we're going to do a few examples on this page, and then we're going to go to the next page where we have a solution set. But we'll talk about that in a minute. So it says, what values does the variable have to represent for the equation or inequality to result in a true number sentence? So essentially, we have to solve for the variable, right? What value or values does the variable have to represent for the equation or inequality to result in a false number sentence? So we're just going to focus on the true part of this question. So we have y plus 6 equals 16. This is a basic addition equation. So you're going to do your little upside down t thing. To get rid of the number on the left-hand side of this, we've got to get rid of the 6. So it's being added here. We want to do the inverse operation, which is subtracting or subtraction. Y equals what? 10, yes. All right, so we know y has to equal 10. When we have an equation, there is one value of y that will work to solve that equation, okay? So you should be writing this down, because when you get home and you're like, I'm confused, I don't know how to do this, you will have examples to look back to. okay? So y equals 10, we could go ahead and do our check real quick. So if we have a number plus 6, it's got to add up to 16. So if we say 10 plus 6, kind of again focusing on the side that we substituted in, what is 10 plus 6? 16, yeah, and that's what we were supposed to get, so this all checks out. All right, now you'll notice in example B here, it says y plus 6 is greater than 16. Right, so that's an inequality. It's not an equal sign, so we call it an inequality. And the steps for solving an inequality are exactly the same as solving an equation. So you're still going to do the upside down T thing. You're going to subtract 6 from each side. That'll isolate the variable. You're going to be left with y on one side, and you're going to be left with 10 on the other. So now, instead of an equal sign, because in this case it does not equal 10, we need to look at the inequality and bring that symbol down. So in this case, it's greater than. So y is greater than 10. Any questions so far? The steps are exactly the same. You just bring down the inequality instead of an equal sign. Okay? So, in this case, if we want this expression, or this inequality, y plus 6 is greater than 16 to be true, we could use any value that is greater than 10. So who can give me a number that's greater than 10? We'll check out, see if we're right. Aiden. 12. Okay, so we're going to rewrite our equation, or I'm sorry, inequality, and we're going to plug in 12 to see if we're right. Because if we pick a number greater than 10, this should work. All right, so what is 12 plus 6? 18. So is 18 greater than 16? Yes, very good. So one thing I want to point out is that we got an answer of y is greater than 10. Everybody, in the world should get that as the answer to that. Now, as far as the check portion of this that we did over here to the right, every person could pick a different number, right? Don't make more work for yourself and pick some crazy, ridiculous number. But, this over here is not the answer. That's just you checking out to see if what you came up with actually works out all right. Okay? So this here is your answer. Okay? Any questions? Yes, Cam. You should be doing a check for all of these, okay? This next one, we have the same type of thing, except for we have a new inequality symbol that I'm not sure you guys have seen yet. All right, so we have y plus 6 is greater than or equal to 16. All right, so that means when you solve this left-hand side, right, it should, or evaluate it, it should be greater than or equal to 16. Does that make sense? It's like half greater than sign, half equal sign there. It's like the hybrid of the two. All right, so again, the steps are exactly the same. You're going to subtract 6 from each side. You're going to get y is greater than or equal to 10. So if you look at this example compared to the one above, you are going to be able to include 10 as an answer here in example C, where in example B, you could have 10.000 going on for a long time, 1, and it would work, right? It could be the teeniest amount bigger than 10, but it still has to be bigger than 10. In C, we could include 10. So an example we gave in an earlier class for an inequality like this is in New York State, for example, and different states are different, but we'll just use New York State. You have to be 16, at least 16 to drive, right? So that means you can be 16 and drive, you can be 17 and drive, 18, anywhere 16 and up, okay? Sometimes you might see a kids menu, right? And the kids menu may say for kids 12 and under, right? So that's a different scenario where the highest amount could be 12, right? So anything 12 and below. So when you see the or equal sign, that means it also includes that number. Anyway, we could check that, bless you, by plugging in the 10 in this case to see if it works. And then if you choose that, I would also pick, honestly, I'd pick one above 10 to see if you've got that on the right side of the number line. So y plus 6 is greater than or equal to 16. Who can give me a number greater than 10 that we haven't used? Malaya. 13. Okay, so 13 plus 6 is greater than or equal to 16, so we would get what here? 13 plus 6. 19 is greater than or equal to 16. Right? Is that a true statement? 19 is greater than or equal to 16. Yeah, so we're good. All right, let's do maybe another example, and then we're going to go on to the next page. Let's look down here at this example F. Okay, 3G. Who can read that for me? I'm done. Michael, go ahead.
3G is less than or equal to 15.
Very good. And I like how you corrected yourself, Michael, because you read these left to right. Okay, so you're going to start with 3G and then say less than or equal to. Remember the alligator mouth opens to the bigger thing, right? And it points at the little one. All right. So anyway, we have 3G is less than or equal to 15. How do I get rid of that 3 stuck with the G? Jacob, nice and loud.
A big T underneath inequality.
Actually, we don't need the big T in this one. Upside down T. Cassie? Divide, yeah. What's going on, Jacob? You good? Oh, nothing. Okay. Anyway, so you're going to divide each side by 3. But I like that you're thinking in terms of that, that we need to do the same thing to both sides. So if it makes you feel better to do that, to show that you've done the same thing equally to both sides, that's fine. All right. So anyway, what is 3 divided by 3? 1. So 1 times G is just G. All right. And then 15 divided by 3 is 5. And what inequality do I want in between there? And less than or equal to. All right, so you're not changing this, kids. Eventually, when you get into some harder math, there will be scenarios that cause you to do some different things. In 6th grade, you're just going to bring that right down, okay? A kid had a question earlier today, which was a really good question. They said, Mrs. Lehman, what if it was written the other way? So this is the same inequality. It's the same exact inequality, just written kind of in reverse. So you would still solve it the same way by dividing by 3, and you would get 5 is greater than or equal to G, and that seems a little more confusing to some people. Personally, what I would do is I would rewrite this and put the G here, but make sure it's still pointing, the inequality is pointing at the G. You got your or equals sign. So G is less than or equal to 5. Does that make sense? You know how with an equation we can just say it was A equals 2, right? We could also say 2 equals A, right? So they're interchangeable. These you can flip too, but you can flip this and write the G first, but we have to pay attention now. It's not just an equal sign. We have to make sure it's still pointing at the little guy, opening up the mouth to the bigger number. Does that make sense now? You just got to switch it, all right? So anyway, we're going to move on to the next page because we have a few more things we need to do. All right, so it says, example 2, which of the following numbers, if any, make the equation or inequality true? And you'll notice up here, let's circle it in blue, you'll notice a possible set of numbers, all right? So we want to figure out which of those numbers will work. Now, one method we could do is go through each of those numbers, plug them in, and see if they work. But instead what we're going to do is solve the inequality like we just did, right? And then we're going to go through and see which of these numbers meet our criteria, okay? So we have m plus 4 equals 12. We're going to do the upside down T that Jacob spoke of. What do we need to do to each side of this equation? Subtract 4. Very good. So m equals what? 8. Not everyone. All right, m equals 8. So we could go ahead and check that. So anyway, if we had our solution we're going to make our solution set. So we're going to put any of the answers that work in our own little set over here. So m equals 8. Is 8 up here? Yes, it's right here. So we can put 8. Are there any other numbers that are going to make that equation true? No. When you have an equation, only one number is going to work. So there you go. 8 is our only option. All right, let's look at B. If we have m plus 4 is less than 12, the same process applies. We're going to subtract 4 from each side, and we're going to have m is less than, oops, I just kind of gave that away. M is less than 8. So instead of an equal sign now, we're just going to bring that inequality sign down. Everyone with me still? All right, so we know m has to be less than 8. So what we could do is go through and figure out which of these numbers is less than 8. All right? Is 0 less than 8? You start with your lowest numbers. You want to list these from least to greatest. Is 0 less than 8? Yes. So that's a possible solution. Is 3 less than 8? Yes. Is 5 less than 8? Is 8 less than 8? No. Good answer. It is not less than 8. So these are the only numbers out of this set of options that will work. Okay? So it's kind of like pick all that apply. All of these will work. Again, you could go through and say, okay, I'm going to check with one of these. M plus, oops. What am I doing? Hold on. M plus 4 is less than 12. You could go through and say, okay, 0 plus 4 should be less than 12. Well, 4 is less than 12, so 0 did work. Let me try 3. 3 plus 4 is less than 12. Is 7 less than 12? Yes. Now let's try one that we didn't say works and see if it gives us a weird answer. All right, let's do 14. 14 plus 4 is less than 12. Is 18 less than 12? No, it's not. 18 is not less than 12, so I'm glad we didn't pick 14 as a value. Does that make sense, everyone? All right, let's go and do D. Skip C. Let's go to D. Actually, no, pause that. We're going to go back. We are going to do C. All right, so we're going to solve f minus 4 equals 2. What do we need to do to each side? Plus 4. Add 4 to each side. We have f left on this side equals what? 6. Now, one thing I want to talk about is when you have an answer, f equals 6, and you go up to your solution set, and there's no 6 up here. A lot of kids are tempted to write 0 as the answer, but 0 is not our answer. 0 is an actual number, right? So we would just do this and write empty set. Or maybe you may see none written, but none of those answers are going to solve or satisfy that equation. Make it true. Okay? Another example that I'd like to show you, just so you know, is down here. When you have a number that's a fraction, right? In this case, f we'll look at. Okay? We have 1/2 h is greater than or equal to 8, right? So we know when we have 1/2, that's like saying h divided by 2. Nope, not divided. It's being multiplied by 0.5. We are dividing by 2, all right? Is greater than or equal to 8. Essentially what we've done is we've said 1/2 times h, right, gives you h over 2, right? That's why that works. Now we would do our steps to get the h by itself, which we would multiply by 2 in each case. We would get h is greater than or equal to 16. So again, here's our answer, but we need to figure out which of those, that is a terrible set of brackets, all right, what works from up here? Are there any numbers that work? No, because we don't have any that are greater than or equal to 16. So we're going to put an empty set. Okay? Your homework this evening is to practice that on your own on pages 73 and 74. There are 8 problems. Thank you guys for watching. I hope you have a great day. Thanks for watching Math with Mrs. Lehman. Don't forget to like and subscribe.
Bye.